Okay, great. So now we're going to hear from IBM, and it's Renato Recio, who is an IBM fellow and also a system network chief technology officer over at IBM. So this is going to be kind of response like how the vendors are kind of helping in deploying SDN or building SDN solutions.
Thank you.
Great.
All right, so my agenda today is I'll start with a couple of OpenFlow clients that we've been installed in with NEC, our switches with NEC, and then I'm going to talk about, I talk to about more than 100 clients a year, and I haven't met a single client in the last 18, 24 months that isn't interested in software-defined networking. In terms of virtualization automation and simplifying virtualization, that for the most part, this is in the enterprise. And then the second case is using OpenFlow to simplify the physical network. And I'm going to cover both of those. I'll start with what are the issues that these clients tell us, the problems that they face, what I've heard from them, and then the requirements, my perception of the set of requirements that come out of these discussions, and our point of view on how you can address those and areas where the industry needs to, in our opinion, focus more on. So we'll start with two engagements that I think NEC has already talked about yesterday. The first one is Tervella. This is a financial client. They like the fact that this provided much more rapid convergence in the fabric than running the traditional layer 3 protocols. And they used the NEC OpenFlow controller and our 8264 OpenFlow switch. The second one is Celerity, and it's a similar type of client. It's in the financial space. They want a very low latency. The latency on the 8264 is less than a mic, and they wanted to be able to automate the network configuration. What I'm going to talk about next is, from these discussions that I've had with clients over the last, 24 months, 18 months. I've been doing this for about 6-7 years now. What has been the issues that they surface? And we'll start with, in the beginning, we had Ethernet. Metcalfe's Ethernet was used to interconnect stations, initially through, hub topologies, which became switches, which grew into this tree structure. And this tree structure worked very well in the campus environment because most of the traffic in the campus was north-south. And it worked well in the campus also because you can break out that access layer, layer 3, and you didn't have to worry about virtual machines running around in your data center environment. So we in the industry have used that topology, and we've taken that topology and said, let's deploy that same topology in the data center. And in the data center, there are some differences when you repot that same topology in the data center. The first one, Microsoft published a paper in 2010 where they basically described that in cloud data centers, in service provider data centers, by the way, the clients I talk to are mostly service providers and enterprise data center clients. So in the cloud environment, 75% is east-west traffic. And in enterprise data center environments, it's more like 50-60%. It's basically the net of that paper. The data center has different performance needs. At layer 2, fiber channel is going to be here for a while. And a lot of clients that have used fiber channel, they want to use FCOE. They want to go to FCOE for convergence. And to provide that kind of service, you need a lossless traffic service for Ethernet, and need to allocate bandwidth to that service. We also have networks that are used for clustering inside of a database, which is a small network, or clustering in an HFT or in a financial analysis type environment, which requires very low latency and has a much larger scale. And then lastly, the model evolved into this virtual compute model, which went from these static workloads that were resident on physical servers to workloads that moved around. And when they move around, whatever state is in the network needs to move around with that workload. And oh, by the way, the workload for the service provider environment needs to be, is multi-tenant, where the IP address spaces are completely overlapping, and you need to be able to support that. And you need to be able to support that efficiently, meaning if two virtual machines need to talk to each other, let's say an app tier and a database tier. So in our case, in our clients, it's a WebSphere talking to a DB2. More than likely, they're going to go through a firewall or an IPS or both. And to provide that, you don't want to have to go, if those virtual machines are sitting co-resident on the same server, you don't want to have to go all the way to the physical appliance at the top of the tier, at the top of this tree structure, and then come all the way down. There needs to be a more efficient way to do that. So I think I've covered most of the issues with this repotting. So what I'm going to talk about next is what are the clients that I talk to, what are they seeking? What are the requirements? And we'll start at the bottom here, optimized fabric, and we'll work our way up. So in terms of an optimized fabric, they want the fabric to support converged flows, where those converged flows could be storage and could also be clustering traffic. They want to be able to have that fabric be flat, very low latency, and if possible, one single manager that simplifies the management of that topology. So I'm not managing 1,000 switches, I'm managing a cluster of switches, 1, 2, in the tens. The workload needs to be, the automation, the virtualization needs to be automated. And there's some waves here that I'm going to go through in the slides that are coming up on this automation that we see as steps towards the end goal. And then the last piece is an integrated software solution where it's not just a single manager, but it's also be able to provide network services like a connectivity service or a pathing service or an FCOE forwarder service. Or you can keep going down this list, a firewall, et cetera. Be able to provide that on the stack and use that from different vendors. And then, so what we'll start with is, I'll start with the virtualization piece. And if you go back 10 years in the x86 world, I can't do that in Poughkeepsie. If I say that in Poughkeepsie, they correct me and say, you have to go back 40 years, Renato, to when you were a little kid, because we've been doing this stuff for a long time. But if you go back 10 years in the x86 space, life was kind of simple for network administrators. They didn't have to worry about workloads moving around in the data center. They didn't have to worry about these umbrellas of security appliances that cover a part of the data center. And when you move a virtual machine out of that part, it's no longer covered by the umbrella. Because it was static. It was a static workload, and you configured it once, and you were done in the network. We've gone from there to a workload-aware physical network. This is where we are today. This is using technologies like IEEE 802.1 QBG. And this type of an environment provides dynamic workloads, and it coordinates the synchronization of layer 2 network state that's in the physical network with the virtual machine. So when a virtual machine comes up, that network state is applied in the physical network. And when that virtual machine moves around, all of that state moves with it. But in our view, to provide a higher degree of tenant diversity, we need to go to this model that's an overlay model. Thomas Narton in our group, my department, has been working in the IETF, and we're pretty happy and encouraged that in the Paris IETF meeting, it looks like the MVO work group is going to get chartered, and I'm hoping this is going to lead to IETF RFCs very quickly. We're hoping. And the goal here is to be able to provide this dynamic workload environment, but make it multi-tenant, and let you configure that physical network once. You provide an overlay on top of that physical network, and now you configure that physical network to the physical servers. You don't configure it anymore to the actual virtual machine that's running in the physical network. You do that configuration on the overlay network. And so that lets you have multiple overlay networks, a Nestle network, a Unilever network, a Coke network, et cetera. That if you want it to be a cloud provider, you can provide those services for. And then that switch, that overlay switch, is controlled by a software-defined networking controller, which is the platform that you see in the picture here. So what are some of the requirements for this virtualization piece? Well, one is be able to take a virtual machine and identify the set of ports that it has, give them an identity, create a group. So there might be a group of these that you're going to do load balancing across because they're all doing the exact same job. They can be placed in the same VLAN. They have the same security checks that need to be run against them. And then be able to connect those groups through middle boxes, where the middle boxes could be a firewall or an IPS or a load balancer. And it could be a virtual or a physical middle box or a combination of the two. And then be able to interconnect those groups through these middle boxes so that any traffic that goes through those groups, virtual or physical, has to go through the middle boxes that are in the interconnected virtual network. So this is the set of requirements that we've received on the virtualization layer. And what I'm going to cover next is the set of requirements that have to deal with the physical fabric itself. I'll start at the bottom. So the first one is, I think in terms of HSSG and IEEE, this one's getting solved, is high bandwidth links. We have clients that are seeking 40 gig links today for their servers, and looking forward to 100 gig. Be able to provide a converged network is next. So FCOE, all the storage options. Be able to do RDMA. There is a set of customers that. So we've done an analysis. We've done an analysis for database, transaction level, not net pipe, micro level benchmark, but at the transaction level of InfiniBand QDR. DFDR is next, but InfiniBand QDR with Ethernet 40 gig. And if you look at the numbers, it's the gaps. It's no longer a meaningful, larger than 10% gap. In many cases, it's 1%, 2% gap at the transactional level. And this is with different, latency switches. Okay, InfiniBand switches versus, best of breed Ethernet latency switches. And then the last piece is be able to do the link configuration, the link discovery and configuration that's needed in the data center. And then the top part is provide this scalable fabric that from our point of view, it would be nice to be able to have the fabric be able to do this joint multipathing without having to do that in a physical, create a, I'll take one vendor's example, fabric path A topology that's been configured physically different from a fabric path, B topology. Be able to have that in the control plane discoverable, or in the case of OpenFlow, in the OpenFlow control plane that's sitting in that controller, discoverable, and set up those disjoint paths. And there's some work that needs to be done from my point of view, from my vantage point, in terms of standardization for that, because, for example, there is no way for today a fiber channel device to say, I want two disjoint paths, because the model for fiber channel today is two completely different topologies, topology A and B. And again, we have some clients that have been using Fibre Channel for a long time. They see that as, they're risk averse in terms of moving somewhere else. And so for those clients, we see, FCOE as something that we need to be able to provide even in this OpenFlow environment from my vantage point. And then, switch clustering, secure fabric services. Let me go through this one. I'm not going to spend much time on that. So let's talk about the link configuration requirement. So today in the data center, we use LLDP, we use DCBX. We've in the case of IBM, we've shipped DCBX and QBG on our physical switches and on our virtual switches on the DVS 5000V for VMware, which is VMware is a major requirement for us. And so you need to be able to configure the DCBX settings in an OpenFlow environment in the enterprise. You need to be able to configure the priority flow control, the ETS, the QCN settings. And you also need to be able to use LLDP not just for discovering the fabric and discovering the fabric topology, but also for these more frequent events, like in the case of clients that don't want to go to that last step, that don't need the multi-tenant diversity and want to stay in that middle column of the virtualization that I covered, to be able to run a QBG type discovery and configuration, so that you can set up the port profiles that are associated with a virtual machine on the physical fabric. There's several options for how to provide that with OpenFlow. And I'm sure you folks can think of a lot more than the three that I'm covering here. I'm just trying to give some examples. One is proxy all those messages to the platform controller, the SDN controller. There you have to look at the scaling issues associated with that. Another option is kind of rototill the switch, LLDP, DCBX, and ECP implementation, so that some of that runs in the switch. The more frequent events are done at the switch, and the less frequent ones are done elsewhere. And then the last one is let the switch run those protocols. Let it run LLDP, let it run DCBX and QBG, turn off forwarding, and then have the controller use, for example, netcomp to be able to extract the LLDP MIB databases out of all the switches so that you can see what the neighbors are, and from that create the topology, the paths that you want to create. I'm not sure if that's an issue in terms of sufficient CPU resources and how much time it would take to do that. From my vantage point, most of the implementations today are in that first category of the slide that I covered. And then to provide this multipathing requirement, the switches use one of those options, turn off layer 2 forwarding, connect to that controller, have them all connected to that controller, and then the controller can basically discover the switch adjacencies, compute the paths, and when, let's take the example of Fibre Channel, when a new initiator comes on, it can request this, and it can request piece. Doesn't exist today in FCBB5 or FCBB6, but it can request a disjoint path, which you would need to provide some additional information that isn't there today in order to provide that disjoint pathing. Without that, you would have to have multiple fabrics. And then for virtual environments that don't have Dove, your VSI manager could sit in that SDSN controller platform. So our view of this sort of environment, SDN environment, is the set of steps that you're going to see here. Start with the physical network, which consists of those physical devices and virtual devices. Provide this overlay driver in this controller. And part of that overlay driver is also a connectivity service, which I'll show as we fill this out. Provide an OpenFlow driver that can control the switches. Provide an application interface between what's underneath that controller operating system and the services, where those services could be provided by, in our case, IBM, or it could be provided by a third party, and include things like a pathing service, which I tried to describe a little bit of the issues there with the pathing service, a connectivity service to interconnect the virtual machines, and SAN services. And sort of the value that we see in this is, the OpenFlow value is to decouple that switch control plane from the data plane and have a pod level. You can start at a small pod, you can grow to a larger pod, and eventually to a data center class control, single point of control of the network. And then the value of the DUB network is to be able to provide this multi-tenant environment that decouples the virtual network completely from the physical network, so that you don't have in the physical network the configuration, all the configuration state that's associated with these virtual machines. And then the last piece is these network services that run as applications on top of this controller. So that's sort of the feedback that, from my vantage point, I'm seeing from clients, and that's pretty much it for me. Thank you.